According to the National Electrical Code, a separate junction box is generally required between a transfer switch and the main panel. The National Electrical Code sets the standards for electrical installations to ensure safety. The transfer switch is required to be installed in a readily accessible location. This accessibility is crucial for maintenance and in emergency situations. The transfer switch must also be able to be locked in the off position. This lockable feature provides a safety mechanism to prevent accidental energizing of circuits during maintenance or other situations where power needs to be positively disconnected. The junction box itself has specific placement requirements. It must be installed within 6 feet of the transfer switch. This proximity is intended to minimize the length of conductors and facilitate easy access. The junction box must also be accessible for maintenance, similar to the transfer switch. This accessibility ensures that connections can be inspected and maintained without difficulty. The circuit connections between the transfer switch and the main panel must be made in accordance with the manufacturer's instructions. These instructions provide specific guidance on wire sizes, torque specifications, and other critical details to ensure a safe and reliable installation. The National Electrical Code is a comprehensive set of standards governing the installation of electrical systems in the United States. Its purpose is to protect people and property from hazards arising from the use of electricity. It is important to adhere to the National Electrical Code when installing electrical systems to ensure safety and compliance. Ignoring the National Electrical Code can lead to dangerous situations, including electrical shocks, fires, and equipment damage. Here are some further considerations. Firstly, local codes and regulations may have additional requirements or modifications to the National Electrical Code. It's essential to check with your local electrical inspector or authority having jurisdiction to ensure full compliance. Secondly, proper grounding and bonding are critical for a safe electrical system. Ensure that all grounding and bonding connections are made in accordance with the National Electrical Code and the manufacturer's instructions. Thirdly, use appropriately sized conductors for all connections. The conductor size must be adequate for the anticipated current load and must be properly protected by overcurrent devices, such as circuit breakers or fuses. Fourthly, use approved connectors and fittings for all electrical connections. These connectors and fittings are designed to provide a secure and reliable connection, minimizing the risk of loose connections or arcing. Fifthly, label all circuits and equipment clearly. This labeling helps to identify circuits and equipment quickly and easily, which is especially important during maintenance or troubleshooting. Sixthly, when working with electrical systems, always to energize the circuits before making any connections or performing any maintenance. Use appropriate lockout/tagout procedures to prevent accidental energizing of the circuits. Seventhly, if you are not comfortable working with electrical systems, hire a qualified electrician to perform the work. Electrical work can be dangerous, and it's best to leave it to the professionals if you are not experienced. Eighthly, regularly inspect your electrical system for any signs of damage or wear. Look for things like frayed wires, loose connections, or damaged equipment. If you find any problems, have them repaired immediately. Ninthly, consider using surge protection devices to protect your sensitive electronic equipment from voltage spikes and surges. Surge protection devices can help to prevent damage to computers, televisions, and other electronic devices. Tenthly, install smoke detectors and carbon monoxide detectors in your home. These detectors can provide an early warning of fire or carbon monoxide poisoning, which can save lives. In addition to the physical installation, documentation is key. Keep detailed records of all electrical work performed, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be valuable for future maintenance or troubleshooting. When selecting a transfer switch, consider the load requirements of the circuits that will be powered by the generator. The transfer switch must be rated for the appropriate voltage and amperage, and it must be compatible with the generator. Before starting any electrical work, obtain all necessary permits and approvals from your local authority having jurisdiction. This ensures that the work is performed in accordance with local codes and regulations. If you are unsure about any aspect of the electrical installation, consult with a qualified electrician or electrical engineer. They can provide expert guidance and ensure that the installation is safe and compliant. Regularly test the transfer switch and generator to ensure that they are functioning properly. This testing should include verifying that the transfer switch switches properly and that the generator provides the correct voltage and frequency. Consider using an automatic transfer switch, which will automatically switch to generator power when the utility power fails. Automatic transfer switches provide a seamless transition to generator power without requiring any manual intervention. When connecting the generator to the transfer switch, use a heavy-duty extension cord that is rated for outdoor use. The extension cord must be long enough to reach from the generator to the transfer switch, and it must be properly grounded. Never overload the generator. Overloading the generator can damage the generator and can also create a fire hazard. Be sure to calculate the total power requirements of all the circuits that will be powered by the generator, and do not exceed the generator's rated capacity. When storing gasoline for the generator, store it in a properly labeled container and keep it away from heat, sparks, and open flames. Gasoline is highly flammable and it must be handled with care. Before refueling the generator, turn it off and let it cool down completely. Gasoline can ignite on a hot engine, creating a fire hazard. When operating the generator, be sure to provide adequate ventilation. Generators produce carbon monoxide, which is a deadly gas. Never operate the generator in an enclosed space, such as a garage or basement. Install a carbon monoxide detector in your home to provide an early warning of carbon monoxide poisoning. Regularly maintain the generator according to the manufacturer's instructions. This maintenance should include changing the oil, cleaning the air filter, and inspecting the spark plug. Proper maintenance will help to ensure that the generator operates reliably and safely. When disposing of used oil and other fluids from the generator, dispose of them properly according to local regulations. Do not pour used oil down the drain or into the ground. Be aware of the potential hazards of working with electricity, and take all necessary precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses, and use insulated tools. If you are working on a wet surface, be sure to use a ground fault circuit interrupter to protect yourself from electrical shock. In summary, the National Electrical Code typically mandates a separate junction box between a transfer switch and the main panel. This requirement, along with other National Electrical Code guidelines regarding accessibility, locking mechanisms, and proper installation practices, is essential for ensuring electrical safety and code compliance. Always consult the latest edition of the National Electrical Code and local regulations, and when in doubt, seek guidance from a qualified electrician.